I had a quick question, and it's something that keeps coming up for me in the homework, and I'm guessing it's just an identity that I'm forgetting about. But basically, there's all of these things where basically you can turn it into like an e to the something, like you get a more complicated answer, and then you can turn it into an e thing. And I'm guessing I'm just forgetting whatever the identity is, but it's come up like several times in the homework, and I never know what to do with it.
Yeah, it's like my favorite. I mean, maybe that doesn't help you, but so you end up with, at some level, limit as x goes to infinity of 1 plus x, or 1 plus 1 over x to the x.
Yeah.
Do you want to do the super specific one, or do you want the more general case? Doesn't matter to me.
I guess probably the more general case. I just need to like know roughly what's going on. So, yeah.
So let's do 1 plus a over x all raised to the bx. And I've already switched it to x's because we're going to end up having to use L'Hopital's rule. So notice this is going to 1. So as x goes to infinity, a over x is going to 0. So this is going to 1 to the infinity, which is an indeterminate form. So this thing would be equal to, we could e to the ln it. So you'd have limit as x goes to infinity of e to the ln of 1 plus a over x raised to the bx. And then what can happen to the bx?
It can come outside.
So it can come out front. And notice that that limit can go in through the continuous function, e. So we have e to the limit as x goes to infinity of bx times the ln of 1 plus a over x. So far, so good?
Yeah.
Okay, notice that this power, so this is all going to e to the bx part is going to infinity. And then this is ln of, it's an a over infinity, or 1. So ln of 1, which would be 0. And this is still an indeterminate form. And I forgot to say this earlier, but anytime you have an indeterminate form, what are you wanting to use?
L'Hopital's.
Yeah, you want to use L'Hopital's rule. But the thing is that L'Hopital's rule only works in 2 cases. What are the 2 cases it works with?
Infinity over infinity, or 0 over 0.
Yeah. And there's a plus or minus bit that we could also handle, but basically that's correct. Keep going?
Yep.
All right. So do you remember what to do now?
So then do we make the bx part into like 1 over bx or something like that?
Exactly. So this will be equal to, now we need like tall things. So e to the limit, x goes to infinity, of the ln 1 plus a over x over 1 over bx. So notice the numerator is now going to 0. The denominator is going to 0. And so we're getting e to the 0 over 0, which is an indeterminate form. But the good news about this particular indeterminate form is, boom, it's in the correct form, right?
Hmm.
Yay. Keep going.
Yep.
All right, I'm not sure if it'll let me copy paste. I don't quite know how this works. E. It didn't want to let me paste it. All right, so drat. So we have, let's see if I can get that. So we had e to the limit, and then we have the ln of that stuff over the 1 over b to the x, or bx. Shouldn't have erased it. So then, now we're going to use L'Hopital's rule, right? This is where we get all happy. So we have e to the limit as x goes to infinity. Ugly fractions coming. So the derivative of the numerator here will be 1 over 1 plus a over x times negative a over x squared. And the derivative of the denominator will be, you can think about this like a 1 over b times negative 1 over x squared. Questions about those derivatives?
Because a and b are constants, that's why.
A and b are constants, yeah. So good news, those x squareds cancel. Ooh, I like this color. The x squareds cancel. The minus signs plusify each other. And so we are left with e to the limit as x goes to infinity of, it looks like ab over 1 plus a over x, which is a funny way of writing. What happens as x goes to infinity to this denominator?
It just turns into ab.
Yeah. So we're left with just e to the ab. So more specifically, this means that 1 plus 1 over x all raised to the x just equals what?
Okay.
So what's the a and what's the b here?
A is 1, right? And b is x, or b is also 1?
B is also 1.
Oh, so it's 1.
So a is 1, b is 1, so all this stuff is equal to.
Okay.
This is all that stuff was the derivation that that they're using over and over again in this homework.
Okay, thank you so much.
So one thing you might consider doing is derive the whole, like the thing that we just did for ourselves once, have it written up really pretty, and then I'm just thinking about the assessment, then you include the one really pretty version, and then anytime this type of formula comes up, you're like, well, I did it once, and you just refer to my own notes, and boom, then you could just go straight to the punchline without having to do all the limits over and over and over again because you did the derivation once. Does that make sense?
Yeah, it does. Thank you.
Pro tip.